Okay, so today we're going to talk about similar figures. This is going to get us ready for 13.3. Now let's start with triangles. If I have two triangles, and let us say this angle 50 corresponds to that, this is 60, that's 70. Remember, when you add 3, you must get 180 degrees. We will say that these are similar triangles. It means they have the same shape. One is just a bigger version of the other one. Take these two triangles. You could focus on the angles again, but you could also look at the sides. If this is 4.7 and that's 9.4, if I divide 9.4 by 4.7, I get 2. So this side is twice that side. This is 10.8 and 5.4. So similarly, this side is double that. We say that these are similar triangles. So you could read that first statement, two triangles are similar if the measures of the angles are the same, corresponding. We say it's corresponding sides and angles. Also, you can look at the sides. This side corresponds to that side. The ratio is 2 to 1. Take this, divided by that, 2 to 1. On this grid, you can count the dots. This is 3, that's 4. I don't know if you remember the Pythagorean theorem, a squared plus b squared equals c squared. So that's 5. Similarly, this is 6 and 8. So this side is double that. This is twice that. This is twice that. Take this triangle compared to that. In this case, we're scaling down. And you can see here you are scaling up. We are going to use K to represent the scale factor. So let's answer this. For the first pair of triangles, my K is 2. Because I'm doubling up. To get from here to there, I multiply this by 2. 5 times 2, 3 times 2. For the perimeter, now perimeter means distance around. So 3 and 4, 7 and 5, 12. And this would be 6 and 8, 14 and 10, 24. Well, we want the second triangle, so 24 divided by 12, and that is equal to 2. Remember, area of a triangle is 1/2 base by height. 1/2 the base times the height. So take the second triangle, it will be 1/2 of 6 times 8. 1/2 of 6 times 8 will be 24. And the first triangle will be 1/2 of 3 times 4. That is 6. If you divide 24 by 6, we get 4. You don't get K, you're going to get K squared. Let's look at the second pair of triangles. Remember, if I'm going too quickly, pause the video. For the second pair of triangles, area of the second triangle, 1/2 2 times 2, that's 2. And for the first triangle, 1/2 4 times 4, that's 8. So I get a quarter. For the second pair of triangles, my scale factor, I'm scaling down. So if I take this side divided by that side, I get 1/2. So my scale factor is 1/2. So let's answer this question. What role does K play? So when we compare perimeters, the rule is to multiply by K. So for example, if this perimeter is 12, this one, P is 12, and this one is 24. You multiply 2 times 12. For areas, you're going to multiply by K squared, because area is always square units. So you're going to need to remember this. In another section, you'll be given a figure and you're asked to paint that figure. And you're asked how many gallons of paint will be needed. This is when you're going to need area. You're going to need K squared. Let's talk about circles. Two circles are always similar. Two circles will always have the same shape. Similarly, squares. All squares have the same shape. They're similar. Perimeter of a circle, circumference, is 2 pi r. So if this radius is 1, the circumference will be 2 pi. And this radius is 2. Your circumference will be 2 times pi times 2. This is 2 pi. And this will be 4 pi. What role does K play? Remember, perimeter, you multiply by K. So if I were to take the first circle and the second, and I want the perimeter, let us say this is 2 pi. If you were to multiply it by 2, in this case, you're going to get 4 pi, which is true. To get from here to there, my K is 2. Let's look at K squared. Area is pi r squared. So the first circle will be pi times 1 squared, which is pi. The second circle will be pi times 2 squared, which is 4 pi. If I were to divide 4 pi by pi, my K squared Remember, my k is 2. So k squared is 4. And if I multiply this by 4, I will get that. So k squared, you're going to use k squared for areas, and you're going to use k for perimeter.